Good morning, everyone. Today we will present a primary school mathematics learning activity based on the Malaysian KSSR curriculum under the topic equivalent fraction for Year 4, as stated in the document Standard Curriculum and Pelajar TSKB by the Ministry of Education Malaysia. Mathematics learning should not only focus on procedure but also on conceptual understanding and meaningful application. Therefore, our activity is designed to reflect alternative classroom practice where people actively contrast understanding instead of memorizing rules. Today, we will demonstrate how two learning theory guide our lesson design. First is the constructivist learning theory. Two is rules learning theory. Our presentation will cover four main parts, which one is brief explanation of bomb theory, detailed description of our classroom activity, clear explanation of how the activity apply this theory. Four is the expected learning outcome and reflection. We will also simulate part of the activity to make it interactive. First selected learning theory is the constructivist learning theory. Constructivist learning theory states that learners actively contrast knowledge through experience and the intellective. Instead of receiving information passively, pupils will explore, ask questions, discuss with peers, and build understanding from peer knowledge. In mathematics, this means people should discover patterns and relationships rather than memorizing formulas. The teacher acts as a facilitator, guiding learning through questioning and structural activities. The second learning theory is the Brunner's learning theory. Jerome Brunner proposed that learning happens through three modes of representation. First is the enactive, which is learning through action and manipulation. Second is iconic, learning through visual image. Third is symbolic, learning through abstract symbol. Brunner emphasized discovery learning and scaffolding. In mathematics, people should move from concrete material to visual representation, and final to abstract symbol. This gradual progression supports deeper conceptual understanding. Okay, let's go to the learning activities. The lesson topic that we choose is the equivalent fraction year 4, which the learning area is the number and operation. The lesson objective is the student can identify equivalent fractions using fraction models. Student can represent equivalent fraction visually. Student can write equivalent fraction using number.
Okay, our activity is fraction pizza investigation. In our activity process, there are 5 phrases. First, set induction. Second, an active stage, which is hands-on exploration. Third is iconic stage, which is visual representation. Fourth is symbolic stage, and the last is reflection and discussion. First, we set induction. So we can begin the lesson by showing pupils 2 pizzas. We can ask if one pizza is cut into 2 pieces and another is cut into 4 pieces, can we have the same amount? So this can activate prior knowledge about fractions like 1/2 and 1/4. Next, we can make pupils work in pairs. So each pair will receive pencil, ruler, exercise book, or paper to write down. And the most important is paper pizzas. Okay, in this activity, they will fold one paper pizza into 2 equal parts and shade one part. Then they fold another paper pizza into 4 equal parts and shade 2 parts. Then we can ask, is 1/2 equal to 2/4? So Students physically can compare the sizes, and then they can repeat the activity with 3 over 6 and 4 over 8. Instead of telling them the rule, we allow them to discover the relationship. After manipulation, pupils will draw the fractions in their exercise books. They will draw 1 over 2, 2 over 4, 3 over 6, and 4 over 8. They visually compare them and discuss the patterns. So at that time, teacher can guide discussion, like what happens to the numerator and denominator. Finally, we introduce symbolic representation, like 1 over 2 is equal to 2 over 4, and it's also equals to 3 over 6, and it is also equal to 4 over 8. So at this time, we explain that multiplying numerator and denominator by the same number creates equivalent fractions. So students then complete guide practice questions. And at the end, students can answer questions like, how do we know two fractions are equal? Why does multiplying both numbers work? And can they create their own equivalent fraction? These can encourage higher order thinking.
Good morning, class. Today we are going to learn fraction by using pizza.
So, you all need to prepare pencil, ruler, exercise books. Now, you all look at these two pizzas. This pizza is cut into two pieces equal. This is cut into the four equal piece. Okay, now I have one question. If I eat one pizza from this and two pizza from this, I will eat the same amount of pizza?
Yes.
Oh, that's we need to investigate this.
Alright.
Okay, now you need to fold this paper into two equal parts. Then you center one part of these two parts. Okay, and then you need to draw a circle and cut into two equal parts, and then write the fraction below the circle that you draw. Now you fold new paper into the four equal parts, and then you center two parts. Now you all comprehend all the data is here.
Yes.
Okay, very good. Those they are equal fractions. Okay, now we know that 1 over 2 is equal to the 2 over 4, 3 over 6, and the 4 over 8. Look carefully. What do you notice about the numerator and denominator?
The denominator is increased.
Wow, very good observation.
The numerator also increased.
Oh, this is the marketing, right?
Okay, so in our daily life, when we doing our exercise sheets or exam, we may not have this pizza you can see. We only see the question and the number. So how can we know 1 over 2 is equal to 2 over 4 or 3 over 6 or 4 over 8? Okay, now let us compare 1 over 2 with 2 over 4. So how can 1 over 2 become 2 over 4? Number. Yes, multiply by 2. So if you want to get 2 over 4, we can multiply 1 with 2 and multiply 2 with 2. So we will get 2 over 4. So now we compare 1 over 2 with 3 over 6. Yes, so we multiply 1 by 3, 2 by 3. So we get 6. 3 is 6. Yes. So now we compare 1 over 2 to 4 over 8. Yes, correct. If you want to get 2 over 4, you need to multiply 1 over 2 with 2. If you want to get 3 over 6, you need to multiply 1 over 2 with 3. And if you want to get 4 over 8, you need to multiply 1 over 2 with 4. So when we multiply our numerator and denominator, it must be the same number. Cannot be like I multiply 1 with 2, but I multiply 2 with 3 times. This is absolutely wrong. Okay, before we end our class, how can we know 1 over 2 is equal to 2 over 4, 3 over 6, or 4 over 8?
The trigger figure is the same.
Yes.
The numerator and denominator is multiplied by 77 number.
Yes, yeah, we all are correct. So now I want to ask you all, what is other equivalent fractions of 1 over 2? I want 2 over 4, 3 over 6, and 4 over 8. Yes.
7 over 14.
Yes, very good. You are very good. So you all have successfully discovered these equivalent fractions by yourself today. So fractions can look different, but they can be equal.
That's all for us. Thank you, class.
So, our activity reflects constructivism because students actively manipulate materials. They also work collaboratively in pairs. They also discover patterns themselves, and the teacher facilitates rather than lectures. Instead of memorizing multiply top and bottom, students understand why it works because knowledge is constructed through experience. Our lesson also clearly follows Bruner's 3 stages. First is an active, which is cutting and folding pizzas. Second is iconic, which is drawing diagrams. And the last is symbolic, which is writing fraction equations. So these progressions support cognitive development and prevents abstract confusion. Scaffolding is provided through guiding questions and structures tasks.
In the learning outcome, mathematics understanding, students will understand concept of equivalent fraction conceptually, Students will recognize that size remain constant when numerator and denominator change proportionally. Students will avoid common misconceptions like 1 over 4 bigger than the 1 over 2 because 4 is bigger than 2. In skill development, students will develop reasoning skill, visual representation skill, communication skill, problem-solving skill, and mathematical language use. In engagement in learning, students are actively involved, motivated, collaborative, and more confident in explaining ideas. Hands-on learning increases the participation and the enjoyment.
There are a few of anticipated teaching challenges and reflection. The possible challenges might include some pupils may focus on procedure only, time management, different ability levels, and classroom noise during group work. So, to address this, we can ask probing why questions, prepare materials earlier, provide differentiated tasks, and set clear behavior expectations.
Now, let's go to the Q&A question. Question 1. Why do we need to multiply the numerator and denominator to find equivalent fractions? We do it to rewrite the fraction without changing its value. Think of it like cutting a cake into smaller pieces. The amount stays the same. This helps us understand fraction instead of just memorizing rules.
Question 2 is, can we use the same hands-on and visual approach to learn other fraction topics? So my answer is yes. For comparing fractions, we can use bars or circles to see which is bigger. For adding fractions, we can use tiles or pieces to combine parts visually. It makes fractions easier to understand. In conclusion, our lesson demonstrates how theory can guide practical classroom teaching. Constructivism ensures meaningful learning, while Bruner's stages ensure structured cognitive progression. This reflects authentic KSSR practice where understanding is prioritized over memorization. That's all from us. Thank you.